Awesome. So let me share my screen. Okay. So yeah, hope everyone can see my screen. Welcome to Multimodal Weekly. This is a virtual webinar series hosted by 12 Labs. And for context, we're an early stage startup focusing on multimodal view understanding. We've been meeting on a weekly basis over the past 2 years or so. Here's some of the topics that we tend to cover on a weekly basis. Researchers coming in talk about different different research work happening in the field of foundation models, multimodal AI, broader Gen AI, etc. Developers, partners, product managers talking about interesting application of these multimodal and foundation models in different verticals, etc. Here's some samples session that we did in the past couple of weeks. There are talks focusing on world models to video caption generation to mixture of expert, right, etc. So for today's session, super excited to have Fuyuan Lyu, currently a PhD candidate at Mackey University, to come and talk about his quite recent work called a survey on test time scaling in large language model. So for a little context, in this scenario, test time scaling is one of the prominent research focus of foundation model builders, Gen AI, at the moment. I think from at least from industry point of view, and even in academia as well, there's still some like black box, right? Understanding about what exactly this mean by test time scaling, test time compute. So this survey from Fuyuan and some of his collaborators present a unified hierarchical framework structure along different dimensions of test time scaling research, what to scale, how to scale, where to scale, and how well to scale. So super excited to have him here with us today to talk about a holistic review of this method, different application scenarios, and how he assessed these different aspects. Since this is a pretty small group, I will feel free to send your question in Zoom chat, ask the presenter speak, and then we'll have an interactive Q&A after we finish. So with that, I will stop sharing my screen, and yeah, if you want, feel free to just unmute and go ahead and share your screen.
Thanks. We're seeing the full screen, right?
Yes, I can see your title.
Okay. Hello, everyone. My name is Fuyuan. I'm a PhD from McGill and Mila. This slides were co-prepared with Qiyuan, my collaborator at City University of Hong Kong. So thanks, Janice, for inviting and having us here. And thank you all for coming to the talk. So in the talk, we'll be talking about our survey on test time scaling from this what, how, where, and how well perspective. We also have a web page that we just developed, I think, 1 week ago. So we're welcome to browse and contribute. We have a discuss session about our survey. So any feedback we'll address agilely. So I think in the past 5 years, we have witnessed a significant change in the language model area. Basically, we call that area the age of pre-training. The age of pre-training basically originates from the scaling law paper, which says as long as you increase your number of compute, the size, and your number of parameters for the models, you're going to witness a log linear decrease in terms of your test loss compared with all these 3 factors. However, the pre-training scaling, we are afraid that they are gradually slowed down. This is mainly because the texts we are running out of high quality open text data in our web. So this has been warned by Fu in mid-2024 and officially confirmed by Ian in December 2024 last year. So we're still having a number of compute, and we can design larger and larger model. But without the growth of the data, we're not able to fulfill the scaling law. We're not to fulfill the scaling law as we did in the past 5 years. And the performance is going to stagnate it even if we add the number of compute and add the number of parameters. So what should we do about these techniques? People have been trying to utilizing different ways, try to utilize this kind of additional compute that we're increasing in this era. So this is known as test time compute. So basically, test time compute are trying to allocate more resources into the test time instead of the pre-training stage for the models. And eventually, we want higher level of intelligence for the language model. Here we present a brief summarization, differences between language model and test time scaling and pre-trained scaling. For instance, the test time scaling are more resource efficient. It's very easy and agile to test whether your strategy was working or not. And also, given that it has just been started, it has great potentials. And it's also very quick feedback compared with pre-training scaling, which requires months to get the models. And given this kind of quick feedback features, it extends the participants to basically every possible researchers and even non-academia background peoples, where compared with pre-training scaling, where only people from a few selected large big tech are able to conduct this kind of experiment. This has basically like this kind of advantages or benefits of test time scaling leads to significant increase of publication in the last, I think, 2 or 3 years. But with this kind of exponentially increased number of publications, what we're trying to ask is for we researchers, when we're facing this kind of overwhelming and complex literatures, how should we cope with them? How should we read and analyze them? But also for practitioners, where should they pivot their effort on, and which are the papers that they should be care about, which are the techniques that they should be care about. And for both practitioners and researchers, how do we discuss with each other on these kind of techniques? These are the questions that we need to answer. So to answer these questions, we together with other amazing collaborators, we propose our survey. First, we have a unified and multi-dimensional taxonomy. This is helpful for both researchers and practitioners to understand the test time scaling techniques from all these 4 axes. Also, we have a systematic literature organization and pragmatic analysis. This is more targeting for practitioners who are not very research-oriented, but just want to hand-on with some tools. Also, for the challenges, insights, and forward directions, these are for researchers and exciting opportunities we are trying to explore in the futures. Now let's dive into the details of our research surveys. So here, as Janice introduced earlier, we'll break down the test time scaling into 4 key orthogonal dimensions: what to scale, how to scale, where to scale, and how well to scale. So for what to scales, we refers to like what are the special form test time scalings are scaled to enhance the language model performance during inference. And how to scale means that how we are going to achieve and this kind of test time scaling in the previous chapters, how we're going to implement them. Where to scale covers the task and dataset where people test them on. And how well to scale is also important, as it refers to both the metric for evaluation, but also implicitly, where do we want to lead this domain into? Now, let's first dive into what to scales. So when we're applying test time scalings, researcher choose a special form of empirical hypothesis. For example, for long COTs, people are hypothesis that the prompt are requiring like longer and deeper thoughts for the models, so that we're trying, so a longer output would encourage higher quality of the answers. So these are the hidden assumptions. Similarly, for multiple samplings, where hypothesis that the problems are maybe very diverse and require divergent thinking. So we need to sample multiple answers from the output until it hits the golden answer that we're aiming for. So based on these empirical hypotheses, we further dive the what to scale into 4 dimensions: parallel, sequential, hybrid, and internal. For parallel scalings, instead of generating a single response per query, we generate multiple outputs in parallel and aggregate them into a final answer. Examples such as best of n majority voting. These are actually very classical techniques in prompt engineering, even proposed before the word test time scaling was invented. Sequential scaling, on the other hand, involves explicitly directing later computation based on intermediate steps. Representative methods such as self-refining or COTs. Hybrid scaling, on the other hand, exploits the complementary benefits of both parallel and sequential scalings. It was first introduced, the concept was first proposed by Tree of Thoughts in 2023, and people have been improving, including more and more complex structures into the hybrid scaling techniques. Internal scalings are the hot trendy topic I think, after the publish of the R1 and the R1, because it internalizes the scaling process into the model and automatically determine how much compute to allocate to answer the question proposed. This is a taxonomy for what to scales. Now, after we determine what are the dimensions we want to scale the model on, we also need to determine how are we going to achieve that. So here we break down the how to scale problems into two strategies, inference-based and tuning-based. For the inference-based approach, we further break down that into four essential components: stimulations, which encourage a model to generate longer or multiple candidates; verifications, which filter or scores output based on correctness or other criteria; search, which systematically explores the sample space; and finally, aggregation, which consolidates multiple outputs into the final ones. For stimulation techniques, as it encourages model to allocate more compute to think, it has we categorize them into 5 strategies: prompt, decode, latent, self-repetition, and mixture of models. For the prompt techniques, we are basically relying on the model's instruction following ability to implicitly encourage longer outputs. For decoding strategy, we're tuning with we're modifying the decoding process to encourage model to generate longer and detailed samples. Latent strategy is very similar to prompt strategy, but instead of going to the decode stage, it just iteratively and recursively thinking until thinking in the hidden space until it reaches the final answer. Self-repetition, which generates multiple samples instead of individual ones iteratively, and also mixture of models, which requires we gather the knowledge from the wisdom. Here is a further breakdown of the 5 categories. We summarize some of the representative approach in this table. For the verification, it plays an important role in test time scalings. As for instance, for the parallel scaling, it can directly determine the output samples among the various. And so here we basically people have in the community, people have 2 kinds of verifications: outcome verifications, which directly evaluate the correctness of the output, and process verification, which give stepwise values or stepwise guidelines into the model. So here is a summarization of outcome and process verifications. Notice that process verification and outcome verification can also be called output verification, output reward model and process reward model. Search is more related to hybrid scalings, as search because it provides a structured way to explore the solution space, and it can significantly enhance performance in complex tasks. Search is actually a very mature and developed techniques in other domains. So people have been employing a lot of these techniques, borrow and ideas into language model test time scalings. For example, solutions such as beam search or multi-color tree search. Finally, the aggregation techniques, because aggregation techniques consolidate multiple solutions into a final one to enhance the reliability and robustness of the model prediction. We can categorize them into two selections, which only select one out of the many, and fusion, which fuse many into one. For the tuning-based approach, the tuning-based approach are more related to internal scalings, as they activate a model's ability to devote costs at test time and directly tune its parameters. We categorize them into supervised fine-tuning and reinforced learning. For supervised fine-tuning, we have three kind of approach: imitation, distillation, and warm-up. Well, for the RL-based approach, for the RL approach, we have reward model approaches and reward model free approaches and reward model based approaches. Here is a visual map and comparison between what to scale and how to scale. So we have the sequential, parallel, and hybrid scaling on one side, which usually does not involve the tuning of the models. But also we have the internal scaling on the other side, which internalize the thinking process, either from the sequential, parallel, or hybrid scaling. And in the process, some of the techniques we proposed earlier, such as verification, are optional in certain cases, but some of them are mandatory, such as aggregation for parallel scaling. This is how to scale taxonomy. So third part is where to scales. We categorize the techniques into reasoning intensive and other tasks. Reasoning is a very hot topic these days. People invest a lot of efforts on math, codes, but also we show that there has been works on science, games or strategies, or medical domains. They all benefit from the reasoning capacity of the models. Apart from the reasoning topics, there are many other domains that can benefit from the testing scalings. For example, evaluation or open-ended questions. This is a summary of the benchmark we summarize in this approach. And finally, we categorize the how well to scale, which is the criteria we use for evaluation to the model. We categorize that into four classes: performance, controllability, scalability, and efficiency. For example, for the performance classical, we use that like a lot in our approach for pass rate or win rate. I'm not going to dive into detail of that. The second the classes is controllabilities. So not only do we want the model to be achieve high pass rate or win rate, but we also want to be more controllable of the model during the test time. For instance, we want to generate the model at a given budget. Generate the answer at a given budget. So we need to measure the number of tokens in the output instead of that can also stop the model from the overthinking. So this kind of controllability matrix measure how controllable are the models towards the instructions. The third classes we care about is the scalabilities. We know that for instance, increasing the number of n in best of n approach can improve the performance, but that curve eventually gonna stagnate at some point. So we want to know that how scalable our approach in this process. And finally, the efficiency aspect has been gaining increasing considerations by researchers as we are deploying the language model into the real world. Efficiency is an aspect that we cannot overlook. So we need to consider about that in the test time scalings. This is the final taxonomy of our papers. With this taxonomy, we can do something very exciting about. For example, we can organize the existing literatures into these tables by highlighting what is working on. Here is a more larger font. So we can see that, for instance, for the mind. Sorry, let me show my cursor. For example, for the mind evolve in the first part, in the first part of the figure, we can show that it adopts the commonly used self-refined stimulation techniques. What is different from itself from the other part is that it adopts a functional verification, which is unique of its own. And also for the S1 techniques, it doesn't have much from the SFT part, but it has a novel budget forcing techniques for stimulations. For the organization, we also have an organization on trendy part of the TSM scalings with a very brief actually timeline in these papers. We show that these techniques are complementary to each other's, and there is no single solution that is outperforming others in various aspects. And interestingly, we observe that the boundary between inference-based scalings and tuning-based scalings are blurring as people are increasingly tune the inference-based reasoning path into the language model after they get this path. Finally, we have a hand-on guideline for TSM scalings. These are more pro practitioners and developers who does not want to dive into details of the research project. We also have open handbook guidelines in our web page, where we're welcome you have any comments on our web page. Finally, for the challenges and opportunities, we categorize 4 of them. For instance, first was we believe that more scaling is still the frontiers. We show that there are, for different kind of scaling techniques, there are problems that we need to solve in the process. So solving this problem can still get you a paper, something like that. But more importantly, we need to clarify the essence of the techniques. For instance, recently we have seen some of the heuristic approach changing some of the heuristic approach between the SFT, RL, and DPOs. But how do they really optimally combine with each other in the theoretical aspects? So these are still missing in this kind of domains. And also, for instance, can we develop something adaptive test time scaling approach? This is still remain open questions for the domain. And third part is that we need better and more diverse metrics, which can be helped in optimizing the test time scalings. For instance, we need, apart from the accuracy and efficiency, we also need to care about robustness, interpretability, and bias and safeties. And finally, as the domain generalizations, we witness a very screwed distribution of these existing paper biases on reasoning tasks, and particularly math and code. But there also are emerging domains such as medical, finance, laws, evaluations, stuff like that, that are more practitioner and more can have a bigger influence on normal people's daily life that requires people's attentions. Of course, in this domain, we need to solve different challenges. For instance, how do we explain the results into domain experts? So these are the remaining. These are the challenges we need to overcome in the near future. So in conclusion, we believe that in the post-pre-training era, TSM scaling will be one of the dominant directions on research techniques. So here in the paper, we offer a structured taxonomy of practitioner utilities and open the community discussion, and wishing to engaging more people in our discussion. And finally, I want to thanks to our amazing and inspiring teams. Apart from Qiyuan and myself, we have Zexu from Gaoling, Lei from Salesforce, Wei Xu from McGill and Miller, Wenyue from UCSB, Haolun from Stanford, McGill and Miller, Zhihan from CUSHK, Yufei from McCall, Nicholas from Stanford, Irvin from CUHK, Steve from MVZU AI, McGill and Miller, and Chen from CTU University. It has been a great pleasure working with all of them. And thanks, James, for your invite, and thank you all for watching, and we have a web page, and if you have any questions, email me or Qiyuan. We also have the paper QR code here. So thanks. That's all for my sharing.
Awesome. Yeah. Thanks a lot for your super detailed presentation. Looks like massive amount of work that involve a bunch of collaborators from different organizations.
Yes.
Yeah. From attendees, any like immediate question that you want to ask Fuyuan? Can you just put it on the chat? Yeah, perhaps one thing that I'm curious is yeah. So for this, in terms of like future direction of test time scaling, I think you mentioned on one of the slide about open challenges in future direction, right? Which is
Yeah.
or else, yeah. Out of these, which one do you think are most applicable for industry? Most exciting for like?
I think for the industry perspective, it was the domains, the final ones. So for researchers, I think I just attended Eclair, I think several weeks ago, and I seen an enormous amount of people working on reasoning, especially math and code. But math and code are very important, but they're not like if I'm an ordinary people, I don't care like whether language model can solve math.
Yeah.
Right. I was more caring like whether language model can answer like give me a rough treatment for my 10-year-old kid who were having a COVID or having a cold or flu or something like that. Like what are the like symptoms that they're witnessing. So I think that's more applicable and could have a broader impact and also like a lot of revenues for individual peoples. Benefits for individual people, also can revenue for the company as well.
Makes sense. Okay, there's a question on the chat here from Swati. She said, yeah, do you see on the chat? You answered.
Okay. I'm seeing them. So how can parallel scaling, such as generating multiple output? Yeah. I don't think that our approach can be, or at least not in our survey, we focus too much on multimodalities because multimodality is a very different domains and it seems to be more caring about the alignment, the transmission of information between the different modalities and eventually that output the stuff into the generated models. But I think that is, from my personal aspect, I think the principle of test time scaling can be extended into various domains. For instance, one of my research, we originally, all the previous research were trying to solve the problems all at once, like they're generating multiple outputs at one times. But after like getting the paper, I was just thinking like maybe you can try this solving one problem at a time, and that did work. Like it does like slower the inference speed of the models, but it does like generate much better outcomes than the previous domain SOTA models. So I'm not expert on object detections. I'm sorry for that, but I think that definitely can be extended. It actually, if you have a good verifier of what is deemed as a good bounding box for object detections,
Yeah.
You can generate multiple box on the image and determine like which one are the best.
Yeah, I think on the slide on where to scale, I think general purpose where to scale multimodal is one of the category that you include. So
yeah, but the where to scale are more like a bias, not bias, like focuses on the image Q&A stuff like that. So it doesn't so I think Abi was asking a different question. Yes, but thanks for the info. Yeah,
great. let's see. I think like from an industry point of view, test time compute is doing mostly on the it's more assimilated with the inference side of thing,
Yeah.
which is post training. And in your survey here, you talk about those 4 areas of how to scale on inference, which is stimulation, verification, search, and aggregation, right?
Yeah. Yeah.
And out of those 4 areas, like, yeah, which one do you think is the, like, from an industry point of view, which one a company should invest the most on?
Verification. I think people are. I think earlier I said it's a screwed distribution on math and code. We believe the reason for that is it's very easy to get a good mathematical or code verifier, because people have written, like this kind of scores, and it's very like you have this kind of Python interpreters easily available for you to get some intermediate results for the code. So I think the verification is a key, like the key bottleneck of test time scalings. And for industry, it's better to focus more on that and develop domain-related verifications. And that other part of the stimulation, search, and aggregation can be, this kind of techniques can be borrowed from the academia. Yeah.
Mm-hmm. Got it.
And also, I want to clarify that like test time scaling is not solely related to the post-training team. Like that's a I don't know why people think about that. Maybe the O1 and R1 like predominant people thinking, but I think test time scaling has a longer history than O1 and R1. So like COT, majority voting, these are all test time scaling, like naive version of that. Yeah.
Makes sense. Perfect. I guess the final question that I have, since we pretty much out of time, is I think in your PhD webpage you mentioned that you're pretty excited about like data-centric AI, right?
Yeah.
And like I think this is the idea around like how do you get high quality label data to foundation models. How do you see like data-centric AIs going, especially in the domain of multimodal? Like for us at 12 Labs, it's definitely like challenging to get high quality video annotation, right? To like
video
captioning tasks, video question answering tasks, and I'm sure that
that's something like I've been thinking about. I think that can be answered with my previous answer, which I think that verification is a bottleneck of why the test of scaling has not been generalized to many other domains. It's very simple. For example, in the video quality, I think it's very hard for us to get high quality video annotations, and it's very time consuming and costly to get that labels. I think that's why like industry can contribute more to the problems, because in the community we really don't have that much resources to get a label data. But eventually, in my belief that eventually what we are going to have is we're going to have a small part, like a medium-sized, highly annotated data, which are produced, I don't know, maybe by companies, and we are going to have a vast amount of unlabeled data, or language model, or word model labeled data. The correct word should be foundation model labeled data, which are somehow less quality, but that foundation model has been aligned or aligned with the golden preference in the human standard. So it's somehow like semi-supervised learning. Yeah.
Perfect. Awesome. Well, thanks a lot, Fuyuan, for spending time presenting today. And the recording of this session should be available on YouTube probably in next couple of days. Be sure to
Sure.
with everyone as well. Thanks, folks, for joining today. And yeah, excited to see some of the future work that you will present on data structure AI and other domains on test time scaling as well. See how that can be applied to those multimodal models.
Yeah. Thanks.
Bye.
Bye.